Hello, thank you for joining me in this presentation all about machine learning on the most important day of the week for the AWS Australia and New Zealand Community Days 2020, because this is Machine Learning Day, and machine learning inside of AWS is absolutely my favourite subject. I'm an AWS machine learning hero, and my day-to-day is helping people learn about machine learning inside of AWS. So I'm actually creating a course all about the AWS Machine Learning Specialty Certification, and I'll talk to you more about that at the end of this presentation. But the project that I want to show you right now is actually something that I have been creating for some time, and I do detail somewhat inside of the course as well. And the problem that I've got that I'm trying to solve is all about Lego. And it's all about unsorted Lego, because I don't know if you're like me or the household I live in, but we have boxes full of Lego that's all mixed together. And it would be really great if we could sort that Lego into the different types of bricks that we have so that we can easily build stuff. And my dream is that maybe I can build the ultimate Lego sorting machine so that we can just tip all the Lego in the top and it'll sort all the Lego for us down the bottom or out the side, or however it's going to work. That's kind of my dream. Now, I'll acknowledge for you right now that if I was going to build that, it would definitely include some kind of mechanical componentry to that. It'd be like a robot or something that could load stuff and to push stuff around. And that's kind of outside the scope of this presentation, so let's just park that for a moment. What we're going to look at is the other two parts to this, which is the vision part and the intelligence part. So we're going to have images of Lego bricks come into this system that we're going to create, and then we want to classify them based on the brick that we can see. So we're going to use machine learning to do that. It's a classic machine vision and image classification kind of problem. So we're going to look at these two components, and we're going to try and build this out of AWS services. Now, out of all of AWS, there is lots of machine learning services going on in there. And I would love time to be able to talk about all of these, but we just don't have time in this slot. Ask questions at the end if you want, and I'll be available throughout the day. We can talk about all of these services that are available. We're going to look at using SageMaker image classification built-in algorithm to do this. It might not necessarily be the best way of doing it, but it's absolutely a way of doing it, and it's an extensible way. It's a way that you can configure it to work just as you want it to work. And so that's what I did. Now, for the project, and really for any machine learning project, you can split it up, broadly speaking, into three different parts. We have to get the data, we have to create a model with the data and an algorithm, and then we perform inference. So in other words, we get lots and lots of images of Lego bricks, then we train a machine learning model to recognize those images of Lego bricks. And then we ask that model to be able to classify new images that it's never seen before. So that's essentially the sorting machine actually working. And it's at this point that I need to let you in on a little secret. Machine learning is kind of easy. Now, I don't necessarily mean that completely, but actually with a lot of the tools that we have in AWS, it kind of is easy. The thing that's difficult is getting the data, because to make a quality machine learning model, you need to have good quality data. And for a deep learning rooted solution like we're using now with the image classification algorithm, which essentially uses convolutional neural networks under the hood, you tend to need quite a lot of data. So we have to try and find a way of getting lots of pictures of Lego bricks. Now, I could get a camera and get one of the many Lego bricks that I have lying around. This actually isn't a prop. This genuinely was just in front of me. I wasn't planning on showing you. I could get a camera and the bricks, and I could just start to take photographs of bricks by turning them to different angles and having different light sources and things like that. But to take hundreds or maybe even 1,000 images of a Lego bricks kind of take quite a long time. So I did for a while have an automated process, which I had a turntable, and the turntable was computer controlled. It had a camera, which was computer controlled, and I would turn the brick around and photograph it from different angles. That kind of works, but the trouble with that is you still need to be there to take the brick off and put the brick back on. It just doesn't scale to a decent number of bricks. So I had another idea, and that's to use virtual images of Lego bricks. There are open source libraries out there with definitions and models of all of the Lego bricks that have ever been created. So we could use these 3D models with like a rendering software that can render 3D images from those models, and maybe we could use those images to train our machine learning algorithm and create our machine learning model. Now, we could absolutely do that, and I have done that, but I had to go through a few processes and a few steps in order for that to work. And I'll explain what I did now. So you can have a look at this image of a Lego brick here. It's a nice, neatly rendered image of a Lego brick, but it looks so neat and so tidy that we can kind of tell it's not real. And if you can tell it's not real, and I can tell it's not real, then a machine learning algorithm will also be able to pick up on that it's not actually real, or more to the point, that it doesn't look like an actual image of a Lego brick when we take the picture for our Lego brick sorting machine. So let's go through a few steps to make this image look a little bit more real. So the first thing I'm going to do is I'm going to introduce some noise into the image, just some random values into the image, which makes it much more like something which is coming out of a real world camera. If you zoom right into an image of a Lego brick or anything else for that matter, with most cameras, you'll find some noise in that image. So let's put some of that in so that the algorithm thinks that it's dealing with a real image. The next thing we can do, and this might actually be one of the most important steps that we can do, is we can reduce the size of the image. And this does two things. First of all, it kind of generalizes the image quite a lot. And so now actually it's beginning to look like both of these images are the same. The real brick and the rendered brick actually kind of look almost the same, and you might not be able to tell the difference between the two. So we're making great steps towards the machine learning algorithm also not noticing the difference between the two. Now, this also means that when we actually take a photograph of a Lego brick, when we're doing our inference at the end, we also need to reduce the size of that image in order for the classification to work, but that's okay. That's a relatively easy step for us to make. So let's do that. But let's do one more thing and take even more data out, because as the more data that we take out of this image, the less data that the algorithm has to process, and it makes our training job easier. So now we've taken all the color out of the image as well. So instead of having 3 color channels of red, green and blue, we've now just got a one single value for every single pixel inside of this essentially 2D array of values. An image is just a 2D array of values. So we've got a really small amount of data that represents a Lego brick. And ask yourself this question: if you look at this, can you still tell that it's a Lego brick? And I think you can. And so a machine learning algorithm can learn from this too. Now there's one last step that I want to take to adjust the image of this brick, and that's looking at the background of the image. When we're coming to do our classification, when we're taking pictures of bricks, they could be sat on your hand, they could be sat on a tabletop. That tabletop might be made from different surfaces. There might be some shadows cast around as well. So how do we make sure that the machine learning algorithm doesn't get thrown by that? Well, we look at the background, we take the background out, and we replace the background with different backgrounds, maybe of a similar nature to the ones it might see. And then we use a script that we're going to use to basically produce all of these images of Lego bricks. The script is going to rotate the brick around to different angles. The script is going to have the lighting source come from somewhere slightly different. The script is going to have one of these images in the background, and it's going to rotate it every now and again into different random angles, so that the machine learning algorithm, when it's looking at these images, sort of gets used to the fact that something that's in the background is in the background and you can kind of ignore it. The thing that matters is this brick that's in the middle. Now, it doesn't know it's a brick, but it's the image that's in the middle of the image that it's trying to classify. And so I did that. I created a script, I ran it up on multiple EC2 instances inside of AWS, and put the data in for the 3D models and generated lots of images of fake Lego bricks. And this is a sample of the images that I created. So they're low resolution, they're black and white, they've got random things randomly placed in the background, and the bricks themselves are randomly lit and are at random angles. So this is the data that I collected, and it's time now to move on to the training stage of creating our machine learning model. Now, as I said before, the algorithm that I'm going to use is actually one that's built into SageMaker inside of AWS. So the image classification algorithm is a built-in algorithm that AWS engineers have already taken and optimized to work in the AWS environment. It's built off of a convolutional neural network, and you can see in the documentation they talk at a fair amount of length about how it works. And you can change all of the hyperparameters, and you can give it the data, and you can tell it how much data you've got. You can do all these things. You can even augment some of the imagery as well, so it can expand out, if you like, the data set that you had. And I'll just go over briefly this process that was followed. So I used a set of EC2 instances to generate the images of the Lego bricks. And I did that just with bash scripting and with PovRay. If you've come across this, it's an open source library which makes and renders 3D images on the command line. So I just put together a simple script that I could repeat and iterate over, spitting out all of these images of Lego bricks. I then put all of the brick images into an S3 bucket, and for this particular iteration I generated 31,000 images of Lego bricks. In other versions I've done a lot more than that, and I can talk to you more about that maybe after this presentation is finished. We then took all of the brick images that were inside of this bucket and I passed them into the image classification algorithm inside of SageMaker. And there are some values. If you are familiar with this, and if you're going to try to do something similar to this, the values, or some of the key values that I used, are written just below that icon there. And so it took 3 hours or so to do this training, which actually isn't very long. But I did have, I think there were something like 10 different Lego bricks that we were training on. So it's not a massive data set. And again, I have done a lot more, and I'll tell you about how I did that maybe in the Q&A section after this presentation. And then we take the model that's been generated and we put it into an S3 bucket. And really, look, I said it before, look, machine learning is easy, the data is the hard part. You see the steps that we had to go through to be able to create the data set to create this model. Creating the model itself, yeah, we had to set some parameters and then we hit go. And the machine learning algorithm does the hard work of generating the model. Now, we might look at the parameters coming out and say, well, it's not accurate enough yet, so we're going to change some parameters and try again. So we're still present, we're still there, we're still operating this process. But the actual hard work of the machine learning algorithm was developed by researchers years and years and years ago. We're just using the tools that are available to us now. So we've got our machine learning model. Now we need to actually make it available so that we can make inference, so that we can take new images, real images of Lego bricks, pass it into the model and get it to predict for us what brick we're looking at. And so we create inside of SageMaker a SageMaker endpoint. This is essentially telling SageMaker, here is my model, put this on a server, manage the infrastructure for me, bring up this service endpoint that I can hit with my image. I can throw my image at this service endpoint and you'll be able to classify it for me. Now, the endpoint on its own is only really something that we can access from inside of the AWS environment. And because my machine isn't going to be on the inside of the AWS environment, it's going to be at my house, I need some way of exposing this service to the outside world. And for this simulation, we're going to be using mobile phones as the machine. We're going to take images of Lego bricks with mobile phones. So for this, all the mobile phones are also not actually inside AWS. So we need to expose this model out to the outside world. And the way we do this is with this very simple architecture. We have a Lambda function. The Lambda function makes the call to the model for us, and it is triggered in turn by a call coming through the API gateway. So we actually have an API available to the outside world where images can be given to the API gateway. It will pass them to a Lambda function. It will then pass it into the SageMaker model and get it to make its inference. It will then pass the results back through the API gateway and back to the mobile device so that we can get the classification of the Lego brick. And so that's how we expose the model to the outside world. And that's absolutely what I did. So now is the time. If you have a phone with you, a smartphone with you, with a camera, then you can scan this QR code and it'll take you to a website that I've created, which will actually hook up to the service that I've created with this model. Now, it is limited. It can't do very many bricks, but it can do some. So if you've got some basic Lego bricks around, then it's maybe worth a try just having a photograph. Try and frame it size-wise like you can see in this demo here. So not too close, not too far away, and be nice and be gentle, and it might work. If you don't have any Lego bricks, then don't worry. Built into the web page, built into the little app page that we're looking at, there are actually some sample bricks that you can send in. And if you press the sample brick images, it'll send that image into the service and actually really do the service. It could easily have made this and faked it, but honestly, it's real. It sends the image in to the service endpoint and will give you an inference value back. So please give it a go if you'd like, and let me know how it goes. It's not going to work all the time. It's not perfect, but it does work. And in a minute, when I come back to do the Q&A, I'll show you that it actually works in real life right now. But what we've done here is, I think, actually something quite interesting and quite cool. We're actually now making inferences, machine learning inferences, from a model that's been trained on fake data. But we've done it in such a way that it still works. And so it's a way of collecting data en masse without actually necessarily having to go and collect real images of Lego bricks. We've got synthesized data for a real machine learning model. And I think that's really cool. And it's something that I talk about in more detail inside the course that I've put together for the AWS Machine Learning Specialty Certification. So the course goes through from absolute fundamentals. So if you don't actually really know what machine learning is at its core, then we do talk about that, what machine learning is, what the different kinds of machine learning models and algorithms are. We actually get hands-on as well, building our own machine learning environment and then building models and algorithms inside of that environment and really getting to understand how we use machine learning to solve business problems. It's in early access right now, this course, so that means that I'm still making it, and now's a great time to jump in and give your feedback as it's being made so that you can see the lessons made that you actually want to see to be able to, pass this certification, but also get to grips with machine learning as well. So please, come and join me on this course, but also connect with me on LinkedIn. I talk about these kinds of projects and a lot more on that platform, and it's a great place to be able to just have discussions about machine learning in general. Thank you so much for staying with me through this presentation. I'm going to be available right now to answer some of your questions, and let's also have a look at the app working in real life.